Good day, grade 11s. Today we are going to look at finding the angle between two lines. So a situation that we are going to be looking at is something like this, where you have one line like that and another line like that, and you are asked to find the angle between them, which can be placed over here. And by angles vertically opposite angles, you can transfer that angle into this, or just use those two lines as they are. Okay, what we are going to make use of here is the exterior angle property and any other means that you can think of that can assist you in finding the angle. So the angle that we are looking for would be A, and then we would have to find B and C. And if you look clearly, B is the inclination of this line, and C is the inclination of that decreasing line. So, and then we can use C and B to find A, because A and B are equals to C by the exterior angle property of a triangle. Okay, so let's look at this example. I've outlined some steps over here. So the first thing that you do, because this looked like that, didn't have that red line. So the first thing that you would do is to, so the situation is like this. You are given the straight lines with just the coordinates. So the first thing that you do is draw a horizontal joining A and F. Okay, that's what I've done. And then you let alpha, remember inclination is measured from the horizontal in an anti-clockwise direction. So you let alpha be the inclination of the line AB, and you let and you find it, and then you let EF be the inclination of EF. So alpha and beta are not going to be on the diagram. You have to now include them for yourself. That's why you have to use this let, so that it will assist you in finding the angle. Okay, so my calculations, so I did okay, let's start with AB. So AB, remember we said tan alpha, or the inclination of AB, is going to be given by the gradient of AB. So the gradient of AB, that's what I calculated here, is then going to give me alpha. So alpha is going to be 45 degrees. All right, then I calculate EF. EF, as you can see, is a decreasing line like that. If it's a decreasing line, I'm expecting that my beta is going to be obtuse. So negative, it tells me that I must find reference angle. That's what I did, 53.13, and then beta is going to be 126.87. and then now, because I have the alpha and the beta, then theta is then going to be 126.87 minus 45, which gives me 81.87. Now, just something that you need to remember all the time is that whenever you're asked to find the angle between two lines, there are two angles that you always have to calculate, and then beta and alpha must always be on the same horizontal. Alpha and beta will be different, but both of them can be obtuse, and both of them can be not obtuse, but both of them can be acute. So, but they will be different, and they will allow you to do the subtraction for you to find beta. And then sometimes the coordinate of F would be up here. And now remember, we said gradient is the same throughout, so I can shift the horizontal from down here and draw it up there, so that the alpha and the beta are on the same straight line, so that I can make my triangle be perfect like that. Okay, let's look at the second example. Okay, look at this example. Now this one is different from the one that we just did. Now, if you notice, the alpha is now over here. It is no longer up there. So now it means we have to split this alpha, or split the triangle into two triangles, right angle triangles, like that. You calculate the small theta there, and then you also calculate the other small theta at the bottom, and then you add them up, which is what I was describing there. Okay, so let's look at how to do that. So I started with the bottom one. If you close that one up like that, you can see that theta 2, if I draw another horizontal at the bottom there, I can transfer. Remember, it has to be measured in an anti-clockwise direction, so I can't use this one because I need from the horizontal. Anti-clockwise direction takes me like that, so I need to calculate that theta 2. So theta 2, if I calculate, this will be the same as that by alternate angles, then it gives me theta 2, which is 50.19. okay, and then for theta 1, if you check here, theta 1 from the horizontal to the line, it is in the clockwise direction. So that means I need this angle on the outside here, this one, which I can then call beta, which is what I did here. Inclination of BC, let it be beta, and then tan beta is going to be the gradient of BC, which is what I did, and then I got beta. Remember, it's negative, so I need a reference angle. So beta comes out as 158.20. And then remember, 158 is beta. I need theta 1. So these two are angles on a straight line like that. So to find theta 1, then I have to subtract this from 180, which is going to give me 21.80, which is the same as that one, but we're just following a procedure, the way that we calculate, then it gives you 21.80. So that means theta, total theta here, is then going to be 50.19 plus 21.80, which gives you 71.99. Right, so please do exercise 4, number 1, BC, and number 2. Now, I have an alternate way that an alternative way that you could have used. See the diagram that we have here, so that the question looks like something which is familiar to what we have done. We could turn this around like that. You see, when you turn it around in a clockwise direction, then it looks like that. So this is the diagram that we have, and then you turn it around, making that C come up there, and then the 2 comes there. So it means it has fallen on the negative x-axis, so it becomes -2, and then the 6 comes up here. Now it's not going to be -6 because now it has fallen on the positive x-axis, so it becomes +6. So your diagram then looks like that. So now if it is like this, then it looks like the one that we did before. So now you can then use your exterior angle of a triangle, and the triangle now looks as normal as the one. So now you don't have to split this one and that one. You just have to calculate your alpha, which is what I did, 68.20. Calculate beta, this one on the outside, and remember this one, the line is negative. The line is decreasing, or the gradient is negative, so we have to find reference beta first, and then the beta is going to be 140.19. Then to find theta, it's going to be 140.19 minus 68.20, which gives you 71.99, a value that is the same as the one that we did here. So you can also use this, but please be careful when you rotate that triangle, making sure that you change the signs accordingly, because if you don't change the signs accordingly, then your theta and your beta are going to be messed up, and then it will give you a wrong theta. But this looks like it's something that we can work with because it is similar to the previous triangle that we have worked with. Okay, so that should do it. So please do exercise 4, number 1, BC, and number 2.